Good morning to all my dear students of MSc final class. Dear students, in the last lecture I told you about the effective mass of an electron which is moving in any Brillouin zone, and we considered the Brillouin zones with the help of Kronig-Penney model. In the same continuation, I would like to introduce another model with the help of which one can understand the formation of energy bands, and we shall learn about the tight binding approximation or tight binding method, which is also actually defined as linear combination of atomic orbitals, that is LCAO method. In this particular approximation, we start with the wave function for a free electron and then construct a crystal orbit by the linear combination of atomic wave functions. That's why it is defined as LCAO, linear combination of atomic orbitals. It means considering one electron associated with one atom, we shall consider a large number of atoms and we will try the overall effect of all the interactions on the electron with the respective nuclei. So here is the case, as I have been telling you right from the beginning, that this dark solid line is a potential plot of a free electron, or rather not free electron, an electron in an atom. And you can see that as the value of distance increases, the potential, obeying the rule of 1 upon r, falls and tends towards 0. But this dotted line shows the potential when a large number of atoms are considered. So initially we shall assume that in an isolated atom, VAR represents the potential energy of electron, where R is the distance from nucleus, and the wave function I will be denoting by phi at a position of R, and the energy E0. Then the Schrodinger equation can simply be written as minus h cross square upon 2m double difference of position, that is del E square phi r, plus V0 r phi r equals to E0 phi r. This is very simple. Most of you have been understanding it. Now, before we proceed further, let us think about certain assumptions which we shall mention in this particular model, that the levels are non-degenerate. Non-degenerate means corresponding to a particular energy there is only one wave function, and you very well know in the quantum mechanics that degeneracy means corresponding to a certain energy there are so many wave functions. Here we shall consider the wave functions or the levels to be degenerate. We shall also consider that there is only one wave function corresponding to each energy, and wave functions are normalized. Normalization of wave function means that if you integrate the square of the wave function from minus infinity to plus infinity or a given dimension, then the value must come out to be 1. And we all know that represents the probability of finding an electron in a certain region. So now two similar free atoms are brought together to form a crystal. The potential of electron in this case will be different from the atomic electron, and let the potential energy in this case becomes VR at a position R. Then, dear students, motion of a particular atom is the origin. We shall consider that the particular atom, one of the atoms will be considered as origin of the system, and the position of any other atom can be represented by a vector Ri, where I denotes the ith atom with respect to the so-called origin, and it's this capital Ri represents the lattice vector, and this assumption, the assumption which we consider here is that electron near a particular nucleus, it means associated in an atom, is only slightly influenced by the presence of other atoms. This is what our main assumption is. We shall not be considering the effect of other nuclei too much on an electron, and hence the wave function of the electron can be given by function phi r minus rj. For a crystal, the wave function will be summation of all these wave functions, and I shall get this is going to be the linear combination of the different wave functions. Here Cj is a coefficient which varies from j equals to 1 to whatever the number of atoms. So according to the Block theorem, we all know that the wave function must be a Block function, and Block function have this particular property that the wave function psi at a position r is equal to summation of these e to the power iota k dot rj. This coefficient has been replaced by this according to the Block function. And Block theorem I have already told you in the beginning of this particular unit. Now if we transform corresponding to lattice vector Rm, this jth number is transformed for Rm, then this equation number 2 will become psi k r plus Rm, and you will see that this r will be represented by summation of all these functions phi r minus rj minus rm. What I did is that r plus rm minus rj, taking negative common here, I shall get r minus rj minus rm, and the same thing I will do here, e to the power iota k dot rj will be written as rj plus rm minus rm, means adding and subtracting, and then it will become simple mathematics. E to the power iota k rm will come out, and for all j this will be the function remaining inside, and I will call this as, this is what phi k r, new vector is rj minus rm. So the energy of the electron will become Ek equals to, and this is what we know, the Ehrenfest theorem, that we can determine the energy using this particular formula, that here H is the Hamiltonian, and we are going for the average of this. For normalized wave functions, we shall consider here now this quantity phi k star phi k d tau, that is for the whole volume. It can I am just writing these values, and I will get phi r minus rj e to the power minus iota k rj, and phi star r minus rm upon e to the power minus iota k dot rm d tau, and then solving this particular integration I shall get the total value. Here this term will be simply n, where n is the total number of atoms in the crystal, hence the Hamiltonian we all know is actually a symbol of total energy, that is kinetic energy plus potential energy. So H can be written as minus H cross square upon 2m del square plus Vr, and this is what I shall get, H cross square upon 2m into delta square plus Vr, adding and subtracting this term, and I shall get this particular expression, minus H cross upon 2m del square plus V dash r minus rj plus V naught r minus rj, and here V dash r minus rj is written like this. The potential energy, the physical meaning of this particular V dash is that it represents the potential energy of the electron